Hey guys, welcome. Today is Monday, so very first day of the week. I hope you guys are fresh and ready for the rest of our unit, which is the water cycle. And today we are specifically going to talk about humidity. So what is humidity? You might have heard the phrase, "Oh, it's so humid today. Oh, it's so hot today, and I hate it." Well, that's what we're referring to. Humidity is literally the amount of water vapor in the air. As water evaporates from lakes or oceans or even plants, it becomes water vapor. And when it becomes water vapor, it goes up into the atmosphere and can turn into moisture that is in the air. Again, water vapor is invisible. It is in a gaseous state, so we cannot see it. And as the water evaporates and becomes water vapor, the humidity of the air increases, which means that the amount of water vapor in the air increases. The air's ability to hold water vapor actually changes and is depending on the temperature. So if the temperature of an area increases, the ability to hold water vapor increases as well. So here's how it works. Temperature increases, there's more evaporation taking place from lakes or plants. And the water, when it evaporates, it becomes water vapor, which is in a gaseous form, and becomes moisture in the air. And as temperature increases, the air or the atmosphere is able to hold more water vapor. So that's how humidity works. Now, one way to express humidity is through relative humidity, and we can call this term RH. RH is the amount of water vapor in the air compared to how much it can actually hold at a given time at a certain temperature. We measure RH or relative humidity as as a percentage. When air holds all the water it can, so suppose it's really hot and the air can hold X amount of water, and it actually does hold X amount of water, it is said to be saturated. This means that the relative humidity of the saturated air is at 100%. It cannot hold even one more molecule of air at that temperature. So when it reaches that point, it is said to be at a relative humidity or RH of 100%. Now, how do you find RH that is not saturated? We know that if it's saturated, it's always going to be 100%. But what if it's not saturated? What if there's only a certain amount of water vapor in the air, but we don't know how much there is in reality? So that's what we're going to try to find out. We use a formula. If you look down here, you can see the formula. It's actual water vapor content in grams per meter cube divided by saturated water vapor content in grams per meter cube, which is multiplied by 100 to give us the percentage of relative humidity. Now, if you know the maximum amount of water vapor that air can hold at a given temperature, that is the actual amount of water vapor in the air, and that's how you're going to calculate the RH. Now, let's look at an example here. Suppose that 1 meter cube of air at a certain temperature can hold 24 grams of water vapor. All right? So, this is how much it can hold at a certain temperature. However, we know that the actual air, in reality, the air only contains about 18 gram of water vapor. Now, this would go here. It is the actual water vapor content. We know that right now it only contains 18 grams. And we also know that it can hold up to 24 grams. So what we do is divide 18 by 24 and then multiply it by 100 to give us a percentage, and that is 75%. So we can say that the relative humidity of the air at that certain temperature is 75%. And of course, there are several factors that actually affect a relative humidity or RH. Specifically, there are two. Now, we already learned about both of these, the temperature and the amount of water vapor. We know that as temperature increases, air can hold more amount of water vapor. so humidity increases. But at constant temperature and pressure, the amount of water vapor in the air changes and the RH changes. So if there's more water vapor in the air, that means there's a higher RH. And if the amount of water vapor in the air stays the same, but the temperature changes, then we can say that the RH changes as well. Temperature is key here. Temperature is a factor that can completely change the RH of the air at a given time. And if RH decreases, but the temperature rises and increases as temperature drops. So as we know, the amount of water vapor and temperature are the two key factors that literally affect how relative humidity works and how we measure it and calculate it. And when we talk about measuring RH, we actually use an instrument. If you look here, this is the instrument that we use. It's called a psychrometer. Now we have a dry bulb thermometer. This one is a dry bulb thermometer. And this one is a wet bulb thermometer. If you see, it is wrapped with a damp cloth. And that is why it is called a wet bulb thermometer. And when we measure the difference in these two thermometers, that's how we find out the relative humidity. Now, a psychrometer is an instrument that is used to measure RH. It consists of two thermometers. One is a wet bulb, the one with the damp cloth like I showed you guys, and the other is a dry bulb. And like I said, the difference in the two temperature readings indicates the amount of water vapor in the air. If there's a larger difference, that means there's less water vapor in the air, which means that there's lower humidity. If there's a smaller difference, it means there's more water vapor in the air and there is a higher humidity. So how a wet bulb thermometer works, it's a little bit different than dry bulb thermometer. The dry bulb thermometer is something that we use to measure just the air temperature, not humidity. If you wanted to measure just the air temperature, you would use a dry bulb thermometer. But we need to use a wet bulb thermometer to actually understand how humidity works. So what happens is the wet bulb thermometer has a damp cloth, right? And as air passes over the wet bulb thermometer, the water in the cloth starts to evaporate. As the air evaporates, the cloth cools down. And if the humidity is low, if the water content in the air is low, the water will evaporate more quickly and the temperature on a reading on the wet bulb thermometer will drop, right? But if the humidity is high, only a small amount of water will actually evaporate from the cloth and the change in the temperature will be small. So if it's small, it's a higher humidity. It means there's a lot of water in the air already. And that is all the content for today. I hope you guys had a great time and I hope you guys will complete your activity schedules for today. And I will see you tomorrow in Zoom. Bye.